to DEK Technologies and to another OpenStack Meetup. Before we start, actually, I would like to thank Nikolai, which is here somewhere. Yes, here he is. Because he has been the one actually so far handling all the OpenStack meetups, and lately gave us the opportunity to organize and present this meetup. So thank you very much from our side. And also would like to thank Ahmad here. He's going to present from SICS. He's going to present today together with the Italian office guys. Here they are. Yeah, so thank you guys for being here. And thank you as well for being here. It's nice to see you all here. Yes, my name is Stefano. I'm going to start with it. I work here at DEK Technologies as a Empower Engineers. We call ourselves Empower Engineers, which is basically engineers which are motivating what they're doing and capable of creativity and innovation in this, let's say, flat organization. We have a really flat organization, and we don't actually have these typical hierarchies and so on. So that's the reason why we came up with this idea of having an OpenStack meetup here in our office. Yeah, that's how it started, basically. Yes, then if you want to know more, basically about us, we have the general managers here, both from the Swedish office, Magnus, and Michele, somewhere, where is it? Yeah, down there, yes. From Italian office. Actually, the Italian office is actually the one mostly working, hardly working on OpenStack. They have a collaboration, a partnership with Mirantis, and they also support or sponsor the OpenStack Meetup group in Rome. So, thank you guys for being here, taking part in this event. Yes, so let's get started. This is today's agenda. So we soon gonna start then with Ahmad. He's gonna give us an introduction, a speech about OpenStack and Docker containers. Basically, he's gonna tell us his experience and design choices while developing OpenStack in the SICS data center. So yes, welcome. Come on. Thank you.
Okay, thank you. Thank you.
Yes.
Okay, so thank you everyone for being here, and thanks to Stefano and Magnus for inviting me to come and give this talk. Yes, as Stefano said, I'm going to talk about our experience kind of while we are trying to deploy OpenStack, and we were looking at what are the different choices, and then we came across this idea of having OpenStack deployed inside Docker containers, and then we give it a try. So he will just talk a bit about it, and we'll see. So before I start, I'll just give a very, very brief introduction about me. So my name is not here. My name is Ahmad. On the first time, Ahmad Al-Shishtawy. So I'm a senior researcher at the Swedish Institute of Computer Science. I don't know if you heard about it. It's just here in Kista, a few minutes away. I'm in the distributed computing group inside SICS, which is like a small unit inside it. You can check on this website to see there are different activities happening there, but it's mainly about large-scale distributed systems and algorithms and big data analytics and cloud computing stuff. My personal interest is in self-managing systems and this kind of elasticity or auto-scaling. So during my PhD, I was doing this stuff, and I was working with auto-scaling and elasticity control for these NoSQL data stores like Cassandra, and this kind of how can you scale it based on the incoming workload. And I'm also interested in multi-clouds and this new kind of edge cloud. I don't know if you've heard about it, which is these small kind of clouds that are very close to the user. So they have different names. They call it like cloud-based fog or mobile edge computing, which have like small data centers and base stations. This, now telecom companies are kind of interested much in this, and like stream processing. So how I start to work with the OpenStack, it was during my PhD when I was doing this elasticity controller, and I wanted to test it, and there was no cloud. It was like maybe 5 years ago. So okay, we have the servers and there's OpenStack, so let's install it. Of course, at that time it was, I think, the wholesome release of OpenStack, and it was have to deploy it by hand, like going, getting the packages, reading the manuals, going into every configuration files, typing it. But it was done. Actually, it's still. How can I? Anyway, so it's still working like now up to today at SICS, and it's used for research. Many master students are using it, but it was a pain. So now SICS decided to make a data center, which we are going to talk about it a little bit, and then they I was involved in discussions on how we are going to do this. So I was saying, no, we are not going to, and I will not do it again to try to install OpenStack by hand. So this is like the story how we can try it. I said, okay, we must have some other more simple tools that we can easily deploy OpenStack and experiment with it, and maybe easy to like remove it and redeploy it again and try the production in some easy way. So in this talk, I'll give you a brief introduction about the SICS data center. They call it SICS ICE, which is I don't remember. We'll see what it means. And then we are going to look at the different options, or different ways that are available today to deploy OpenStack. And then I'll talk about which one we choose and why, and like, briefly the steps that we went through during this deployment. So what is the SICS ICE data center? It is like a vision that where we want to be. So it's a part of SICS, but it's like in Luleå. That's a branch of SICS that is in Luleå. And it's a data center that is focused on kind of research data center. It's not like for not like Amazon. It's more focused on helping, for example, strengthen universities, companies, and research, and increase the knowledge in Sweden related to all these cloud technologies. And the vision is like to have around 3,000 or 4,000 servers that will be in this kind of nice building, and it consists of like 5 labs. You will have these different rooms, and it will offer like so there will be these different kind of research rooms and the area here for like a showroom area and rooms for work. And this data center, the interests of it spans kind of everything. So it starts from the environment, like the location and nature and the impact on the environment, to the how to build the electricity and all these heating and cooling, how to build the servers, how to arrange them in the room, up to like the servers, the storage, the network, and then we are like kind of the OpenStack is kind of at the top there is like different kind of software. So it covers the research of the entire data center from building the whole until you have applications on your, and also how to configure it and like different research topic across kind of all the layers. And I'm out of battery. So what will be offered at this center is like a compute and like a cloud, which we have now. We have online and running is something that we developed at SICS called the HOPS, which is a Hadoop-based platform as a service, where you can go and have your Hadoop cluster and have Flink and Spark and start, it's managed. So we deployed it and we are managing it, but you as a user just log in and you can use this platform. The next thing is what we are going to talk about, which is OpenStack. And then there are like other, also serve like this demonstration space, infrastructure that you can do experiments. For example, there are lots of measurements and sensors that you can, for people interested about this stuff, that can go and also work with it. And there are already some companies that are started doing research about these other layers. So currently, this is a picture of the kind of where in Luleå, where it's the data center is. So it's kind of inside a building, which is just one. We have now one module in it, and it's already started operation this year in January. And the future is that there is like already the design phase is done. So this is how it will look like. So they are building a new building for the data center. And this kind of the design that you saw on the first page with these 5 modules. And it's planned in 2018 that it will be this research data center, hopefully ready for you guys to come and do research. So this is what we have now, which is kind of a room inside a room. So it's like emulates a server room or like the environment inside the data center in a room. And then it looks like this cube, which everything is there. So the people doing the other kind of research on the environment and the connectivity and the electricity can do their stuff. And it's going to expand to have multiple modules. And this is like what we have today. We have this number of cores and RAM and hard disks and the network connectivity. So this is how the status of today, the SICS data center. So by the way, if anyone have any question, so this is like a meetup, so if you are free, you can stop me and so this was another data center. So about the SICS ICE cloud goals, when we were thinking about having this cloud part of the data center. So what the goals that we were thinking about? So first, we want to offer a reliable public cloud infrastructure, so that researchers and universities or whatever, anyone who's working, probably they will need a cloud to do experiments or collect measurements or whatever. So it's that kind of an important part. So we must have a public cloud infrastructure available that is kind of high availability, and you have a reliable storage. And it also should be kind of simple to manage and simple to do upgrades and reconfigure. But we also wanted to have kind of private clouds, because some people come to us and they say, okay, we want one rack and we want to have our own private cloud. So also, beside the public cloud, we want to support private clouds, where you can, someone can come and ask, and it should be customizable, because probably something like OpenStack is very huge and many projects, and no one kind of, they have different requirements for different organizations, so it should be kind of be easily customizable, and also we don't want to spend lots of effort in provisioning it. So if they come, we want maybe in a few hours to make it up and ready. We don't want to kind of put a big effort in this customization and deployment. And also to support, for example, if they develop something, like let's say a new scheduler for OpenStack Nova or something, and they want to test it, we should be easily to take their custom components and test with it. And also we are like kind of a research data center, so we don't want to use kind of something that is an older release of OpenStack, so we want to use the latest technologies that are available and test with them and have answers if someone comes to ask us about this. So we want to be on the latest, and that's why we were thinking of, because probably a normal company will try to take something that is stable and that is working perfectly, but here we want to experiment with new ways to configure and manage new ways to deploy and redeploy and latest technologies of OpenStack. So this kind of the mindset when we decided, okay, we are going to have a cloud infrastructure. Okay, so what about OpenStack deployment methods? So as everyone probably saw, OpenStack is very simple and modular and consists of just three, like you have compute, you have network storage that sits on your hard disk, and you have a nice dashboard, and it's simple, like each separate components that communicate through API, and very nice. But once you go a little bit deeper, they call it, you go to the conceptual architecture. But then you see the conceptual architecture. So now it starts to be different. So you have many, many services, and this is like provisions that, and this is provide this, and this stores the images in that. But then when you go a little bit deeper to the, I think the admin guy or something like this, you get the logical architecture, which kind of. So I mean, probably everyone here knows. I don't need to say it. OpenStack is very complex. There are many, many different projects like compute or heat or whatever, and each one of them consists of different kind of processes like API and different inside each service. And then they depend on other things, like they depend on some database, a queue, and you find like there are different queues, different databases. And then there are different interactions between them, like different components depend on other components, so they will not work if they don't exist. And then to make it even worse, when you want to, in production, you want high availability, so you want these things to be kind of replicated. So it gets very, very complex, and the relations between them becomes even more complex. And then it's the problem is networking. So when you go to the guide, you say, yeah, there are different ways. You have this compute node, network node, you have this interfaces, that interfaces, and the network node. You have this bridge and that VLAN, and it's really, it gets very big. And before you get scared, like wait, because it's getting worse. So I don't know. So now OpenStack decided to have this no more integrated releases. So OpenStack was having these 6-month cycles. So for every 6 months, they have a coordinated and integrated release where they have some core components. So actually, so they start after this kilo release. So actually, this architecture was from that release, and we don't have this picture anymore because now each project kind of manage their own cycles, and they recommend to have these 6 months, but it's not like mandatory. And like the OpenStack before, they were making sure that all these components are working together properly, and everything is kind of have the right dependencies. But this is not the case anymore. So now they have this big tent model. And the reason on that, if you read a bit, why is that? So they say, well, that is because OpenStack became too small and too big. So they say it's too small to fit all the requirements of every people. Different people have different interests. They want to try different things. So it's too small, cannot satisfy everyone. Everyone has different choices and options. But it also became too big. So now it's something very big that no one wants this integrated big thing that's going to install. So, but although it became this separate project, but they still try to have these coordinated releases. But this gives opportunities for projects to kind of more projects can join this OpenStack big tent. So it maybe gives more choices to people and more maybe will make OpenStack better, but it can have these problems that now they can have some conflict between different parts and components of OpenStack. So now anyone, if you have these kind of 4 things, they can be a part of this big tent. And if you are not actually following, you can feel it that now there are much more projects that are starting to appear that are like under OpenStack. So, and this is the reason. So if we want to go to what are the choices to deploy it, so there is the basic choice, which is like follow the documentation, which is like using the packages divided by different Linux distributions, like Ubuntu packages or CentOS packages, and you just install, you have the servers, you install these packages on the server. So in my opinion, this is a great way to learn OpenStack. And I think it's useful. So when I did that 5 years ago, I learned a lot. And that was useful. But it's not practical, and it's not for... and it will like deploy a toy OpenStack. It will not really deploy something that is for production. And then there are many of these configuration management tools. Like I think the famous one like Puppet Chef, Salt, Ansible. We all can have like an official OpenStack sub-project or something that is going to deploy OpenStack to you. Yeah, so this is an option, but deploying using these, it might be slower, so you have to fetch packages and install them on each machine, and so it can be more time-consuming, and it's an option, but it can also be, you have to go to all these, they have different names like cookbooks or whatever, and edit them, and then maybe it's not very flexible. And then there is a image-based deployment where they have some tools that they prepare like a server, like an image that you can, like the set of releases for like I think Ubuntu, for example, they have this cloud release or something that have OpenStack and this stuff. And there are some tools that they can create these images for you that are ready, but it still have the same problems that are before. And then when you want to kind of update, then you have to get a new image and push this entire new image to the server, so maybe the updates are becoming more expensive. And then there's another way that you can deploy OpenStack in containers or in VMs. So from a long time I heard it was available that many people recommend that you, for example, have a VM instead of having the physical machine. You have some kind of VM where you deploy the control part of OpenStack, so you can move it or upgrade it independently, or having some containers where you have some services. So if you, in this way, you are more into this microservices architecture. When the current approach is that you have one physical server and you have many services deployed on this one server, and then they are kind of you can have this. You can have some conflicts between them. You can affect each other. Then maybe upgrading one independently for other might be a challenge. But when this microservice architecture is like that, each machine you have just one service and they interact through some APIs. But of course, you cannot afford to have one physical machine for each service. So having these microservices using something like Docker, it becomes more practical. And it's like separates each service, and then it becomes more flexible, that you can maybe move things around, scale out, or adapt it in different ways, or upgrade it in different ways. But we will talk more about this. In addition to all these, there are many kind of projects that will help you implement these methods. So these automated deployment tools. So I think everyone heard about the DEK, which will help you to deploy like a kind of all-in-one deployment where you have all services in just one machine, so you can play with it, you can test it. And then there is a project Cola, which is we are going to talk about more today, which is provides production-ready containers and deployment tools for OpenStack. So it gives you the containers and some tools that help you to deploy these containers and have a cloud. Another interesting project is the OOO, which is OpenStack on OpenStack, so that's why OOO, where they deploy what they call an under cloud, which is used to deploy an user cloud or an over cloud. So they kind of use OpenStack to control the hardware and then use these OpenStack services to deploy and modify and change maybe one or more user clouds. And actually, I'm seeing that now these two are kind of getting merged. So OOO are using the containers here to deploy this over cloud, and then there's also a project called Fuel. And there are many other tools that if you Google, you will find lots of them. So yeah, so we are looking into this today. Maybe we are interested also in trying. So if someone maybe try them, maybe you can talk about after the break. Okay, so what are the kind of if we talk about this containerized or the Docker approach of deploying what are the advantages? So one advantage is that it's fast because you already have these Docker images prepared, and all you have to do is like to push them to the server, and then they can run, and they are kind of reliable because I don't know how many knows the Docker. Okay, so Docker is kind of so there's virtual machines, and then there's Linux containers. Linux containers are some way of isolating and making some service running in an isolated space. And Docker makes containers on Linux easy because it provides these images which contains everything this service needs, and it provides you the tools that you can easily bring up this image and make it like a process running in this computer and the server, and also provide you with kind of a registry or a hub where you can share these images, and then you can, if you want to run some service, you can easily pull it from the registry to your machine, use some Docker commands to bring up the container, and then it's running. It makes it easy to manage Linux containers. And using also containers makes it like a composable building blocks. So you can have, as we said, they have this microservice architecture, so each container will have just one service, and you have many of these containers in a kind of a registry. And then when you want your system, you can get kind of the components that you want, because Docker makes it kind of portable, so you can have a container, run it and test it and make sure that it's working correctly, and then Docker is kind of taking the responsibility for making it running or portable. Another advantage that you have independent upgrades. So as you saw in the OpenStack architecture, there are lots of services and lots of dependencies between them. So you have this problem when maybe they are independently developed. So maybe one project requires a certain version of some tool or some database, another needs another one. So if they are on the same physical server, then you get some conflicts and you get some problems. Here, they are independent. They can have different versions in each one of them. And then if a new release comes out, you can independently upgrade one service. If it's not working, you can easily roll it back, because you have the container for the original version and you have a new container that's with a new version. So it makes it easy to do this. Also flexibility, because it's back to this building blocks. So I mean, you have this cluster of machines. You can deploy containers in one way. You can rearrange them. You can put them together on one machine. You can spread them out. You give more flexibility in an easy way, because now they are like building blocks that you can rearrange. And conflict so I mean, it's easy to patch dependencies. So you have if different projects have different dependencies, now it's not a problem, because they can have different versions of different libraries or whatever. It will be even on the same physical machine, because the containers take care of this. And easier backups, maybe. So they have these data containers, or they have volumes in Docker, where you have a separate container that holds the database or the data of the database independently for each service, and then you can easily make a backup of these, and then if something happens, you can restore it from there. So this kind of some of the advantages, I think, of this. Okay, so now we will just go through of what we have and what we did. So on the data center, we started with one rack, which consists of 18 servers. So each server, you had like 24 cores, 256 gigabytes of RAM. We had 4 terabyte disk for storage, and then 1 disk for the OS, and 10 gigabit networking. So, so usually it's a better way is that you plan of what you want and what servers you need. But in that case, kind of this was done before. I mean, they purchased all the hardware and everything, set it up and linked it, and then they came, okay, we want to have a cloud. So, I mean, there are different ways, but some, I mean, standard way, like you want to have control nodes where they manage this, have a control about OpenStack and networking, and then you have a some machines with lots of RAM and lots of CPU power, and you use them as a compute node. So you separate the compute, and then it makes it more flexible. If you want to have more computation power, you buy more of these compute servers. If you want less, you get less. And then you have a separate kind of set of machines that are not that powerful, but they have lots of storage. And then these are the storage part of OpenStack, and again, you can independently scale them depending on your needs. But in this case, because kind of the machines are okay, they're powerful, and also all of them have good lots of storage, so it was kind of a waste to split it in this way. So instead, what we did is like we spread it, everything on all the nodes. So we have storage and compute on all the 18, and 3 of them we have in them as also as a controller node. So this is like the initial phase. If we find that this is a problem, then it will be easy to remove some of the compute, for example, nodes from the control nodes. So now it looks like this. So we have 18 servers. So 3 of them for high availability. So we have we took the high availability options. So we have kind of 3 replica of each of these OpenStack services. So like database and these stuff are replicated. And there is this keep alive and the HA proxy to make sure that like a load balancing for the for example the Horizon interface, so we have load balancing on the 3 servers, and then we have the compute on all of them, and also the storage is spread on all of them. So for storage we will have the choice of Swift or Ceph, but we decided we tried Swift before, so we decided to try Ceph, because we heard that it's much better, but we don't know yet. We will see. But we have Ceph storage. And regarding the networking, so for the control node, we connected them to the internet, and then we have the default layer that we have this management network, one of them, and we have a network for Neutron, which is the networking part of OpenStack. Okay, so now how we do. So then we decided we were going to use project Cola. So why? As we said before, because it's provide production-ready containers. So you get for each of these services that you need, they provide you with a ready container. So they have Docker, they have shared registry. Like think of it like Maven or something, where you have a Maven repository where you can get dependencies or some repositories for where you get your packages for upgrading Linux. So they have also a registry where anyone can go and share their images, and they compile it for you and prepare the images where you can get it. And this is done by, so these packages is like a Docker containers. So what's nice of it, as we said, that they are prepared and tested, and they are, you just fetch them and then they are ready. You don't need to install or do anything. And then, so why also a nice thing is that they use something called UNFS, where they have, it's a special file system where you can have multiple layers that they are meshed together to give you the final view of the file system. What advantage of this is that any modification, you just add more layers, so you don't have to rebuild the entire image. So if you want to change some configuration or something, you just add layers, which also makes it kind of fast to modify the images. And then also they provide the deployment tools, so they use Ansible, which is one of the configuration and management tools. I think it's also popular, so similar to Puppet and Chef. It's used for deployment and operation and managing the configuration. And as we already said, so how it works is that you have people developing, making images and put it in a registry. And then you, using Ansible, you go to your hosts, and then there is some service containers that talk to Docker, where they're going to fetch the images from the registry, and then kind of deploy these images on your machine. So what are the supported services? So currently, Cola supports many services. So this is kind of a list. I'm not going to read it, but they have most of the basic stuff like Nova, Neutron, Swift, Horizon, Heat, Ironic. Many of the core OpenStack services they already provided. So of course this is not everything, but this is like the most important parts. But for me, more interesting is not these things, but kind of the other stuff. So for example, they deploy Ceph for you, which is quite complicated. Ceph is a storage system that can be used similar to OpenStack Swift. They manage, for example, HA proxy and Open vSwitch and like all these infrastructure components. They also provide it to you in addition to the core OpenStack services, which is I think is interesting. But of course, it's a new project, so it's recent, like maybe a year or two. So it's under development. It's still not mature enough. So, for example, if I want to operate, I want to know how to upgrade it to do. So I mean, if you go to the source code and check it, so it's it's implemented, like how to do upgrades, how to do failure recovery. But it's still we face some challenges when we want to kind of do something. But for other than that, it's a promising. And it's also kind of flexible. So in addition to the pre-provided images that they kind of provide for you, you can build your own image. So they have a build command that you can use to just build the same as they have provided. You can build your own images. But what is also nice and why we like it is because you can configure it to like what you want to build. So you can give kind of this is just a snippet of this build configuration file, or you provide the location of the source code that you want to build. So in this case, we are building the master. You can point to a specific release, or even what is more interesting is that you can kind of maybe fork the GitHub repository, have your own fork of Nova, And then they support also, you can point to either a URL or a Git repository or a local file on your hard disk. You can point it to it here, and then it will use that to build the image. So this makes it a bit, back to our goals, it makes it flexible, so anyone can kind of specify which release they want, or if it's a bit modified, they can give us a URL to the specific version of Nova that they want to use to build these images, which is kind of nice. It's a bit of a tool. And then when we build it, then we'll have these custom images. And it's very easy. You just type a URL here. So what about configuring it? So so now we're back to this. We said that, okay, we want to have it this way. We want to have control and network part here and the compute here. So how we are going to tell that to the deployment tool? So as we said, it uses Ansible. And in Ansible, we have something called an inventory file where you specify what are the hosts that you have and what are the roles of each one. And in that case, in our case, to install it, the first thing you start with is to create this Ansible inventory file, which you start what are the control nodes. So in this case, the host name is OpenStack 1, OpenStack 2, OpenStack 3, up till 18. So just tell it from 1 to 3 is the control group. For the network, you can specify, we told it, okay, 1 to 3 is the networking nodes, and the compute nodes are these ones, and the storage are these ones. So it's that's simple, you just say it. And then, but it's not, if you want to go in details and specify more details, like, okay, the API service should go on that machine, and this part should go, I mean, if you want to go in more details, it allows you to do that. But it's enough to have these basic configurations. And then about configuring OpenStack. So all what you, I mean, I'm just going through some part of the configuration that you need to do. So you need to kind of specify the network interfaces. So what is going to be the management network interface? What is going to be the external interface? And what is to be the neutral interface? And kind of, if you have a domain name and IP addresses that are going to be used. So this is used for load balancing. So this is like a virtual IP address that's going to be used to balance the load between the servers. So you just write them here. If you have some certificates, also for HTTPS, you put it here. So I mean, it's few lines. And then also, you say what services you want. I want SEP, yes. Heat, no, whatever. Swift, yes. Ironic, no. You just say yes, no, yes, no. And I mean, seriously, this is what you need to configure. Just IPs and not more than that. But it allows you, if you want to go in really details and specify certain configurations, it allows you. But they have default values that are community best practice approaches that are put in there. And then if you want to override them, you can also use this global file to override some details that you want. But if you are fine with that, then you just need some IP addresses and interfaces and turning on the services that you want. And then for storage, you need to also, they put a special label on the disks that are going to be used for storage. And this tells Ansible that it's okay to go and format this disk. So, and then you mark all the disks on your servers that you want. For the part of command, you put some label. It's called a set, something that tells that Ansible that, okay, when you find this label on the disk, you can go and format it. So after that, after you prepare the configuration, the deployment step, you run if optionally, you can build your own images. So I put time here to measure the time. So you call build, and you then, in this case, you can point to your private registry or in your own cloud. And we put source here because we want to compile all images from source, and it took like less than an hour to compile all the images. And then you can do they have some pre-check where they go to all the machines that if you remember in the inventory file, you put the name of the host that you're going to deploy. So the command of pre-checks goes on, so this file is the one that I show you with the servers, which lists all the kind of what are the controls, the network, all the hosts that are going to be used. And these are, so to set up Ansible only uses SSH, so it doesn't, so you don't need to install any special thing on these machines. So all the deployment hosts we are going to deploy your cloud, it only needs Docker to be there. I mean, nothing else is needed to be installed. And this doesn't take much time, just go quickly check that everything is okay, it can connect to the machine, all the ports are open that are needed by the services, do some checks. And then after that, you fetch all the images so that all the hosts will go to the registry and take the images that they need to deploy depending on the configuration, and it's like took 15 minutes. And then this is the most important part, that's deploy. That we're going to start up all the Docker containers and deploy, give you a working cloud. And it took like 25 minutes. So this for us was impressive. So after building and doing all these things, in 25 minutes we were able to get a cloud that is working. And I mean, we did it. We are experimenting and playing with it. So we remove everything. It's very easy. There's a cleanup command. We clean up, and it kills all the containers and returns the server to the initial state. And then maybe change something, redeploy again. It becomes very fast to test and redeploy, and maybe go to the configuration, change something, deploy again. In like 25 minutes, we have a cloud. So you have a functional cloud. So maybe I just to show you how it looks like. I can. So it's just a kind of normal OpenStack, where you can have can launch instances. You can have some instances. You can have look at the network topology. And this address that I typed here is it's just a configuration I put in the config file, and it manages high availability. So I have 3 servers, and it kind of balances the load on them. So I still have some time, so I wanted to show that, log into the server just to have a look, and it was this machine. Yeah. So because of the network, I don't have SSH port open, so we will have to, on the password. Yeah. One, two, three, four, five. Yeah. The secret. Okay, so how do you make it full screen? Like, you click it, that's it. I think it's disconnected. So I think we have to, have to do it again. Okay, so this is one of the servers. Great. So if this is one of the control nodes. So if we do kind of Docker
Is it possible to increase the font?
Font size.
Yeah. Did it work?
Yeah, it did work.
It works.
It worked.
Yeah, it's fine. So we asked Docker to show us what is running, so we see that there are many. Okay, because we increased the font, so it's not very. So, for example, let's scroll up. Yeah, because so I don't know how to scroll up. But anyway, you see here that there are, for example, the message queue container, the database container, and then, for example, if you want to, for example, here, I don't know if you see that. This is the container from Nova, the Nova API container. I can use Docker to get an interactive terminal into it. So when I press enter, now I'm inside the container, and then I can just interact something like Nova VM list. Then you just work with the service. Normally, so this is the list of. Sorry, because of the font, it's like it's. So I get, for example, a VM called Node 3 on server OpenStack 5, medium, active, whatever. So now we are inside the container. You can go out. So I mean, you can just interact with it, but all the services are in these containers. That when we run the Docker command, so these are the name of the containers, and each service is running. And if you want to interact with the service, you just go inside the service. So, for example, we can ask this is the Ceph monitor container, part of Ceph that is monitoring the cluster. We can ask it what is the status of the storage, and it tell you, yeah, we have 145 terabyte storage available. And yeah, now it's running only on 10 servers because we were doing some experiments. We wanted to test something else on the other 8. So this is on 10 servers. We have this much. What else? Yeah, I think that's it for now. So I think it's. I think in general we had a positive experience up till now. But yeah, we'll still continue playing with it. But the idea to have OpenStack inside Docker container, I think it's good and very easy to deploy. All the services are already pre-installed on these images, and we just need to fetch the image and run it, and then it's kind of configured and ready. And we have and Coda tool itself provides you an easy way to build these images. So, I mean, you don't do it yourself, so the tool does it for you. And provide you an easy way to describe your cluster. Like, okay, it was a simple file. These are the servers. These are the servers will go there, and then sort of flexible. Provide you a way to customize it and get even your own version of it by forking a repository and changing it and just giving a URL to it. So yes, I think it's in general it's a good experience. So any questions? So yes. So now we are. Yeah. So after running these tests, you are done. You have a functioning cloud. Okay. Okay. So yeah. So yeah.
If I understood you correctly, Docker has to be pre-configured on the nodes.
Yes.
Are you using anything special to configure the nodes?
No.
So you manually install all the nodes and then run the Colla tool. How do you get the nodes up and running? Because you have a base Linux distribution on
Yeah, you
Docker.
just install Docker. That is the main prerequisite.
Yeah, but you don't use anything special to configure the nodes themselves? Like you don't use Ansible to set up Docker on the
To install
nodes?
Docker, no. So what we didn't use it's possible. So what I use is, you know, Tmux.
No.
Okay.
Oh,
Let me
the
show you.
SSH, the session tool, Tmux.
Yes.
Oh, you just did parallel commands.
So if we do like this, so what you see here is that, so this is OpenStack 1, OpenStack 2, 3, 4, 5, up till 10, you can have more. And then when you type something, like, it's typing all of them. And then if you want to do like this, and then you want to do whatever. Let's say you want to go to a specific node. We are push something wrong. Like we are now in node number 4. I can easily kind of zoom into it and maybe modify this command and then go back. So now only this one got a bit different and then run something all of that. So I think Tmux is really a very nice
What's the Linux distribution?
CentOS 7.
Okay. Is that like a recommendation from Colla or?
So the support CentOS and Ubuntu. So when you build engines, you can either choose CentOS or Ubuntu. You can choose binary, which gets the packages from this distribution, or source. So they have these combinations. Yeah.
And I think we're thinking about the same thing, the configuration of the host. What hypervisor are you using?
It's a KVM, but they support, it's part of OpenStack, so OpenStack supports but it supports also others, like they have Ironic, but we didn't test it. They have the Docker, so they have different Docker, but what we tested is the container. Yeah.
The latest Docker requires like 3.10 kernel version.
The what?
3.10 kernel version. The latest Docker application. So did you run into any kernel incompatibilities that for this?
Not till now, but maybe we will. So we are still not online. I mean, we are still in the test phase. So we have the cloud, we tested. It's working. We have VMs up. But it's CentOS 7, so I don't know what kernel it is.
3.10. On CentOS 7.
Yeah.
So if I understood correctly, that you have a physical machine, and then you have a container inside the machine, and then you have services inside the container.
Yes.
Say, for example, Docker Compute.
Yes.
And then inside that container, the user at some point moves into the VM, right?
Yeah, but I mean, it's lightweight, so container is as if you are running as a root.
My point is that by adding containers, aren't we just adding layers between a process which will the user's phone and the actual physical machine? Do you have to go from the user to the hypervisor and then to the container and then to the actual physical machine? Right?
Yeah, yeah.
So what would be the performance penalty that we're paying?
So what they are saying that it's none or not much. But I cannot confirm. But from the Docker community, I would say that it's lightweight and stuff. So I mean, it's not like VMs. But yeah, I cannot confirm that. I don't. Yeah, we didn't really test or compare two one by one.
And then the return message the host phone, the phone in the container, or the phone in the host.
In the container. So everything is in this container.
But the containers, they just are in a separate namespace, so
Yes.
there's no interposition there. So that's why there's
It's
no
almost the same as like running on the machine.
Exactly. So it's basically native as in the machine itself. There's no room for performance overhead. Maybe some, but like
Yeah,
Emulation.
Exactly. There's no, it's not a virtual machine.
They're just separating the processes so they don't see each other.
Just operating system isolation.
Yeah.
Are you using any SDN controller in the network or in combination with Bluetooth? Like Open Daylight or something like that?
So
to manage the physical switch infrastructure, for example?
no,
Nothing like that.
not yet. So I mean, we have the standard Neutron setup with the Open V virtual switch, and V switch, and we have they deploy this HA proxy with the alive to load balance the load between the for access for the user from our side to access the API and Horizon interface. But I think this thing can be added. We did it, we've not yet. Yes?
Now, more about the Docker project as a whole, not in the deployment.
Yes.
Have you considered trying that on other architectures than x86?
No, because that's what we have. Yes. But what about architectures like
Power
no, not yet. I mean, no, we didn't try it. Yes.
Did you run into any issues when it comes to configuring Docker containers with the network, the network configuration part for the Docker?
No.
Was it just straightforward, like, you're just configuring?
Because it's just Docker, it doesn't use any kind of swarm or whatever, it's just plain Docker. So, yeah, you have this command just to install Docker and that's it. Maybe we will. So,
And at the end of the running this container, how much of the Docker this is how small are you using Docker?
So in this one we are having open vSwitch, and so actually tomorrow I was planning to test the bridge. So I want to remove everything because so which one is the one? So maybe if I can.
I guess that these Docker containers, they have host networking somehow. They are not really using the networking. It's usually a Docker container has they have their own IP.
Yes, they have their own instance of the network stack, but they usually use the basically virtual network infrastructure of the host. So if you have a switch on host,
okay, they are configured to use the host networking.
yeah, that's the normal.
Yes, actually, this is one of the deployments. So I'll just update the time. So actually, just changing this line. So how easy is it? So if you say how do you want to. This is the configuration file for the column. So you can tell either Open vSwitch or Linux bridge. It's that easy. So we will play with this one, but so we are going to tomorrow to test the other one. And then we have a cleanup script. So if I go here and type like this one, it's going to disappear in like 2 minutes. There will be no cloud. So I will not do that. And then you can just edit this simple configuration, and you don't need to recompile, rebuild the images because you are using the same images. You are just changing something in the configuration. And then I press enter and go drink coffee. Come back in 25 minutes. I have the same cloud deployed, but with the Linux bridge instead of Open vSwitch, and then I can see something. And then maybe I can also change other things like try Swift instead of set or something. Then So for now we tested this deployment and redeployment, but the next step is to test this reconfiguration and upgrade. So this is like what we are going to do next. Yes?
And just a small question. How easy do you think it would be for a simple user?
Yeah.
Simple user. I want to go home and give Poland try and just.
Yeah, it's very simple. For example, they have this all-in-one. So I'm just doing it between all these. Let's try to get that around.
So there is some documentation.
So here, I mean, you can either, so they have this deployment guide for all-in-one in a virtual machine, and they have also, if you're developing using Vagrant, you can also, they have some Vagrant instructions to get it up and running quickly, and here they have virtual for, like, if you want to have it inside a virtual machine. So they have these, they call it all-in-one deployment. So they give you some guide to have this all-in-one deployment, or in using Vagrant. So in Vagrant, it will actually spawn up multiple VMs and if you are something test environment similar to a multi-node deployment.
Have you noticed any issues with running compute on the management nodes?
Not now, but we don't have any load.
Yeah.
So maybe when the load, when we do some of these tests, maybe there will be, and then we will remove the computer. Yeah. So we just kept it like this, but if we run into problem, we will keep the storage and remove the compute part problem. Any more questions? Okay, so I think we can stop when the break is. Yeah, thank you.
Okay, so I think we can start. So, good evening to everybody. Just want to say thank you to Stefano for this invitation. I'm Giovanni Della Corte from DEK Italy, and together with my colleague Fabio Imperato, we will give you an overview of Murano. That is an OpenStack component, also called the Application Catalog of OpenStack. First of all, my experience with OpenStack, I started to look at cloud computing and OpenStack as one of the first solutions in 2012, 2013, maybe from the Grizzly release. And then in 2014 I joined DEK Italy, and we started to look at OpenStack. We became, with a number of employees, we became members of the OpenStack community, so also started contributing with some blueprints, so suggestions of new features to be added to the OpenStack projects. And then since last year we are in partnership, as Stefano already said, with Mirantis, that is one of the most contributors of OpenStack, and is a company completely focused on OpenStack, just deal with OpenStack. And so with Mirantis we are providing reselling and support and consultant services on OpenStack, installations, configurations, and so on. Well, so let's start with Murano. Murano is an OpenStack project. It has been in incubation till the maybe the release Juno But yeah, since the kilo release, it is up and running pretty well, and it is the so-called application catalog of OpenStack. So you can find, thanks to Murano, into your OpenStack a catalog of applications from which you can build your environment. This project has been launched by Mirantis and is also driven by Mirantis, but it is managed according to the OpenStack rules, OpenStack community rules. So it follows the Big Tent methodology, and so everyone can contribute to this project, can suggest new features, and can write code and develop features of this new code if they are accepted by the community. And so Mirantis just lead this project, but anyone can contribute. Okay, this project, Murano, is a step from OpenStack that usually is involved with the infrastructure as a service service model to go towards the platform as a service or also software as a service. And so Murano is the step towards these new services. And with Murano, cloud users, also the unexperienced one, can have available a catalog, and in a few steps he can create an environment putting together a number of applications and just deploy them and check all the life cycle of this environment in a very easy way if compared with manual installations of this service also on OpenStack or also on, yes, on cloud environments. It is, how we say, it is integrated into the dashboard Horizon with an Horizon plugin for Murano. So it is available via GUI and accessible via APIs, but also with the command line interface. Here we can see an example of a screenshot of the OpenStack GUI with Murano instance running, and we see that there is a tab dedicated to Murano with a couple of subtabs that then we will see in more detail also during the demo that will be had by Fabio. And here we can see a number of applications that the user can find in its environment and can add to an environment that he intends to launch. Okay, yeah, just to review some some of the OpenStack Murano features. So thanks to Murano, a user, according to the cloud philosophy, can self-provision, in this case applications, can use the services deployed, and can manage all the life cycle of his environment. This environment is accessible via portal, how we already said, simply accessible to the user that can select applications and deploy the whole application environments automatically. So in this way it saves time. It doesn't have to go to the IT unit and or issue a ticket and ask for some applications for him, but it just do it by itself. And so how we say the user can save time, and the deployment of a similar environment becomes very straightforward. But here we can see the roles in Murano, and I should say also where the challenging things are in Murano. Because in Murano there are defined a number of roles. The main roles are this that we can see here. First one is the application publisher. The application publisher, when it comes to Murano, is the one that makes the hard work, the most part of the work, because it has to create new applications according to the Murano rules, to the so-called Murano programming language, that has a number of code libraries, and then use YAML and YARC languages. And so the application publisher has to build the packages for Murano. So it has to create the so-called deployment flow. It has to instantiate the resources, to define which resources have to be monitored, and so it has to create the link to Ceilometer, that is the project that cares about metrics into OpenStack. And then into the application publisher has the responsibility also to describe applications and to look at the dependencies, and so to raise dependencies problems to the user when installing, when creating an environment. And okay, and it also inserts some billing rules. For example, when some application requires some licensing, okay, it has to charge the catalog administrator in this case with the costs of the licensing and so on. Then there is the other actor, the catalog administrator, is one that manages the catalog, not only for the Murano, but I should say for every project. And it can publish itself the application prepared from the application publisher, or it can establish rules that allow or disallow anyone to publish the catalog or to access the catalog. It can also establish that that users from a specific tenant can see a certain number of applications, and the user from other tenants can see other applications. So it has the due to define the rules of access to the catalog, to deploy the policies, and also to monitor the usage application, because it has to recoup the costs paid to the application publisher, charging the end user, that is the final user of the applications that have been created from the application publisher. Then, okay, then the last but not least, the end user is the one that uses this environment. For the end user, it's very simple to interact. Later we will say how it is simple with the demo. So it can create the environment, putting in one environment one or more application, and looking at which applications are available into the catalog, it can create the desired environment. So it simply has to navigate the catalog, it can create the environment, and in every moment it can inspect the state of the environment, the status of the environment, and also the metrics, for example, to know also the billing that is up to him. Okay, here you can see the Murano architecture, and so leveraging on this picture, we can also explain the interactions between the Murano components. Okay, I can say that Murano, like every OpenStack components, like we saw in the previous presentation, the big picture from Ahmad, is made from a number of components. So components talk with the external world, talks to Murano via RESTful API, but the Murano components talk to each other via RabbitMQ and via remote procedure calls. Okay, so let's say that the flow of messages that goes into these components to have a Murano instance running, a Murano environment running. Okay, so the user interface, for the user interface, a user tells Murano to start an application, to start an environment that has inside a number of applications. And so it goes to the REST API, so the Murano API in this case. Murano API interacts with Keystone for all the things regarding authentication and authorization of the user asking giving the commands. And then Murano API put onto this queue, the RabbitMQ, commands from the user. The user can also talk to this API via CLI, not just by a user interface. Then the Murano engine will pass these messages, and so will understood what the user wants from Murano, and we create an orchestration template. So in this moment, it starts to enter into communication with all the other OpenStack services. So HIT is the orchestration project of OpenStack, and has the responsibility to contact all other services, so the core components, Nova, Newton for the network, and Glance for the images, and maybe Singer or Swift for the storage. And so when a whole environment has to be created, there is a series of resources that have to be instantiated, prepared, and this is up to HIT that inform the other OpenStack services to prepare these resources. Okay. So at this point, the OpenStack services see which resources are already available. So the resources that have been requested from the user for the environment are all already present, and so just used from these other requests, or are newly instantiated and created from the specific services. Okay, at this point, all this is following a so-called workflow that lists all the actions that have to be taken to put to have all the resources deployed. At this point, of course, some virtual machine has to be instantiated, the virtual machine on which at the end the application will run. For Murano, we have special images, special OS images that contains this Murano agent. Okay, so this is the only different things. This Murano agent that is already inside the operating system image, but you can find them easily. They are already available. So there is, I don't know, Ubuntu with a Murano agent, or whatever operating system available, also with Murano agent inside. Murano agent already knows from some cloud init used inside it, which is the RabbitMQ of reference for it. And in this RabbitMQ, we will find some of the workflow given by the Murano engine, and that is called the execution plan. Later, this concept will be more clear because I'm going to present the package created from the application publisher. So also the execution plan concept will be more clear. Anyway, the Murano agent has to perform this execution plan, and so it can install all the applications that are foreseen by the execution plan. And so we will have the whole environment, the whole application running on top of the virtual machines. Okay. Here in the database, there are information about that you can find also into the catalog. So there is information on the applications, and there are also initially all the workflows for the different applications. Okay. Now we want to give a look at the Murano package. Okay, the creation of the Murano package is the most challenging thing, but it is just up to the application publisher. It's transparent for the user. Okay, the user just can use the already provided application. It is up to the application packager to create this that is an archive file containing these resources that we can see, that allows to define the workflow definition, dependencies among applications, the resources that are required, scripts for configuring the applications and so on. Let's see ahead and let's look more in detail at what each component of the package contains. So the manifest is a YAML file. It is the entry point for the application. It contains general info, that are the info that you see also into the GUI. When you look at an application, you see the author, version, name, similar things. And then it contains also the reference to the classes. Classes is this other folder that is, I should say, very important here because it contains into a YAML file, it describes the workflows that we've seen also in the previous slide. So all the steps that have to be taken to create the virtual environment. So resources, I don't know, network resources, virtual machine that has to be instantiated, storage resources that has to be started to create the environment. Then we have the resources folder containing a .template files that has inside the so-called execution plans, are the ones that are taken from the Murano agent into the virtual machine and are executed to have the applications running on it. These execution plans leverage some scripts that are single actions to be taken into the virtual machine. Then we have a user interface that is a folder that has a YAML file presenting the windows for the interactions with the user. For example, when deploying an environment, the user has to insert some parameters, the flavors it wants, some security information, and so it is thanks to these windows that you can give these parameters. We will see it later during the demo. There is a licensing file. Optionally, there are images, OS images, already ready for the environment, and then just a logo for the catalog, for the specific application into the catalog. Okay, so at this point, it is the most part of the work is done, and just the package. So an application has to be imported into the catalog. Usually, as I said earlier, it is up to the cloud manager to import this application into the catalog. He has the rights to do this, but he can also give these rights to the application publisher, for example, or to a specific user. Okay, so the application can be simply imported from local disk, from local repository, or from the OpenStack Application Catalog that already contains a number of application prepared for usable for everyone. Okay, here so we can see that into Murano we have this subtab manage with package definitions inside, and here you can simply import new packages and so connect to local resources or to the OpenStack Application Catalog and import into your the catalog of this instance the desired applications. Okay, now it is up to the user. The user enters the Murano tab and can look at his environments. It has a number of environments. Entering in each environment, so it can create new environments, and then it can specify for each environment which applications are part of the environment. So it can simply drag and drop applications into the environment, and then it simply launches the whole environment. Okay, so when we have complex environments, when we are going to create complex environments, it is very easy to have a similar deployment because if compared with the step-by-step installation, it saves a lot of time. And then once you have the packages for all the applications you are interested in, you can reuse it more and more times. So the effort is just once to create the packages with the applications, and then you can use it a number of times, saving a lot of time. Okay, now Fabio will present the short demo. Now we will connect via VPN to our to a test bed used for usually for tests. It's not a production, but it is a test environment we have in Italy, and we use to verify and to test every new concept, every project we want to. We want to go into depth. And so also in this case, we have Murano installed on it, and we will give a short demonstration of what is the interaction with Murano.
So I'm connecting, I'm logging in on the OpenStack environment. Okay. So this is the famous Horizon dashboard, and as I said by Giovanni, Murano is fully integrated in Horizon as a plugin. In fact, we have the Murano tab. Here we are starting from a fresh installation, so the catalog is totally empty. And the first thing to do is to import the package that represents the application or the application that we want to deploy in our cloud environment. So this type of task, I want to spend a few words that this type of task is under the responsibility of the cloud provider or cloud administrator. So it's not up to the user to download or import the application into the catalog, but the user must have all the catalog available here with the application. So from the cloud provider point of view, it will have this tab where under package definition you can upload the package. Choosing the three sources listed before, local repository, local hard drive for example, local repository within the company or the enterprise, and a custom URL where the package is stored. So in this case I choose repository, and the default choose is for Murano is the public catalog. So just clicking, I'm going to the OpenStack Community Application Catalog, and under Murano package there is a list of all packages available for the uploading in the catalog. In our demo, we will use Apache HTTP server. So the information that I need is the package name that is listed here. So just copy paste of the package, and okay. And now Murano automatically will connect to the repository and download the package. So clicking on Next, I can choose the name of the application, some tags that can be used by the user to find the application within the catalog, a brief description of the application, And also the administrator can choose to mark as a package, as application, as a public, in the meaning that can be shared among tenants in OpenStack. Next. We can also choose the category belong that the application, for example, application server, and then create. Okay. So now the package is loaded, and we will see it in the catalog. Okay, under application subtabs. Okay, now the user, if you want an Apache HTTP server, just go under application catalog, environments, create its own environment, create new environment, choose new, choose the network where the server has to be connected, and click on create. So the next thing is to choose the application, and here we just see one application, but in general there is a list of all applications, and the user just drag and drop the application that you want, and a new Windows has been prompted, asking some information that the application publisher lets the user to choose. This is the dynamic Windows generated on the fly using the UI.yaml file. So just the name of the application. Okay, we can choose to assign a floating IP or enable PHP support. Next. Okay, in this case, application publisher let the user to choose the flavor of the virtual machine that hosts the application. The flavor in OpenStack is the concept that describes the virtual hardware needed for the virtual machine. So you can choose a small flavor. Here we can select the images that, as said before by Giovanni, have already pre-installed the Murano agent inside the images. We can also choose the EK pair for the authentication, but it is optional. The availability zone, and just click on create. So the first application has been added to the environment. If you want to add more application, just another drag and drop and configure it, navigating in the Windows. At the end, when I'm ready to deploy the environment with all the application, just click on this button, deploy the environment, and Murano starts the deploying following the workflow instruction inside the packages. So here we can see the deployment history with some details here. Okay. So for example, the first thing is to create a virtual machine for Apache server, and then this is uploaded. This is refreshed every time an action finishes and a new one is started. Back to the environments. Also here we can see the status of the environment. For example, for this environment, the status is ready, or that means already deployed and up and running. It is deploying for the Apache M.
You can see it takes some time here.
Yes.
So this is the matter. We choose a simple environment with just one application to stay into the time slot. Because if you have 3 or 4 applications added to an environment, it can also take maybe an hour. Our environment is also a test environment, so it is not so powerful. And so we just wanted to let you see everything and the application deployed at the end. But it is very simple. Here you can't see the real advantages of Murano, but if you have a complex application with a lot of dependencies and so on, it is you have great advantages using Murano.
Okay.
How many compute nodes do you have in this?
At the moment, just
one running.
Yes.
Yeah.
Can you just add like this application to an existing VM instead of spawning a new VM? And
I'm not sure for this because every time on packages require the startup of a new VM, but only it's up to the application publisher to describe the dependencies, the dependence for its application, also in sort of a new VM or to use some VM. But in case of to use some VM, the publisher has to know some kind of information before to publish its package. So I don't know if it is very.
Also the Murano agent has to be provided. And if you have a Murano VM run without a Murano agent inside, you cannot communicate with the queue.
I mean the possibility is there, right? Or expect you to like conform to like their OS specs, so that's why they always have this, spawning of a VM for a certain application. It sounds a little bit weird that they might have flexibility to, you can augment an existing VM with other applications, but of course you can specify the dependencies and.
The VM is
no, I got the point, but there is some information that the application publisher that has already know before the publishing of the application. So, for example, the floating IP of the virtual machine that can be changed from one OpenStack environment or another. But maybe this information can be inserted from the user at runtime. So there are a lot of customization that can be done. So I don't exclude this way, but I think that it is not the preferred one. So it's better to deploy a new virtual machine and toss to your application.
It's a question. So it's this application that's one per VM, or some applications can be spawned on multiple VMs? Or
okay, you can also split your application in more VMs, asking to start more VMs, and then the application during the installation of the application inside the VM, you have automatically configured the dependencies and all the stuff to link the.
But I mean, will it just be independent instances, or will it like scale on multiple VMs? It depends. Can you deploy Apache on like?
I think that it is up to the workflow described from the application publisher. So you can instantiate every resource into the environment, more or less every resource. So what would you do if you want to do it manually? Okay. And so you also maybe have an HA proxy or something similar, but also into the package you can specify to instantiate the HA proxy or
if there are more than one application in the environment, then I say, okay, do I say for this environment I need 3 VMs, or for each application in the environment? For Apache, give me 2 VMs. For database, give me 3 VMs. How you manage the relation between the environment and the VMs and the applications?
And then there's a lot of configuration between
difference.
Actually, if you're going, I thought you were going to show like the actual implementation of the resource file and stuff. But I don't know if you have time or not, or is that in the agenda to how this, to assess the flexibility and the power in terms of creating those packages. What kind of options are there, and can you have like
No, we never tried to. We're also talking about scaling.
No, I'm talking about like, let's say if I have to write this package myself.
Oh, right. Yes.
Yeah. So what? I mean, I see there are YAML files and all those things, but probably some sort of an idea of what configuration blocks are there, or what kind of stuff. Probably then it would automatically also answer all the questions like you can have multiple applications per VM, and you can
It's specified to the classes YAML. All these things. So the one I was showing before is under the classes folder.
Yeah, of course it's there, but I was just thinking how you configured them, because it gave an overview that fine, you have those resource files, logos, images, and everything.
You have to write them by yourself. This is the most challenging part.
These application components, is this like in Juju? I mean, I use this Ubuntu Juju. I don't know if you are familiar with it.
You just had something like Ubuntu Juju.
I only know that it exists, but I never use it.
Because here, you can drop components here. Like you can drop a database. For example, you can have a WordPress thing where you have web server and a database, and we connect it together. And connect them. And when you create one of these application components, you put some scripts that tell you if somebody connects a web server to you, this information has to be transferred to the web server, and this information has to be transferred to the database to be able to connect. And you will send the connection string of the database to the WordPress application, so it knows. So is this doing that as well? These scripts, and they have hooks for if you drop a component here, you drop an application and you drop a database, and then there is some script that will be executed in the other, via the Murano agent in the other server, just to let it know that there is a new component. The connection string is.
Interdependencies among components are there. So, into the packages. Okay, so it is the same.
It is the same thing, that's it. So I understood it.
Yeah.
Okay. So how do you compare Murano like chef and puppet and this configuration like the two?
No. And
is it like some similar?
No, we're not comparing.
Probably use something like chef or puppet as a Murano agent execution script.
So in the workflows, they use something like that?
Into the scripts, they're just.
For example, in the under the script folder of the package, you can insert also bash script per also some puppet file. So it's up to you.
Okay, so then when you compare it to Heat template.
Yes, but it's mainly used for the infrastructure part of the virtual infrastructure part.
It is just for the software level.
What happens from the storage perspective? I mean, you asked for an HTTP server, right? Is that HTTP server saved as a complete image of glance, or is it just another new storage solution that just saves only the libraries, or is it just sets standard set storage? What happens on that front? You use the existing storage.
Okay, this also depends on how the application publisher, which kind of storage the application publisher decides to use for its virtual machine. If I want to create a virtual machine with ephemeral storage, I don't create any volume in Cinder, for example. But if I want to store some info in a persistent manner, then in the workflow, I say, okay, during the boot of the virtual machine, added to the virtual machine is a volume from Cinder.
Now that this environment has been deployed, could you go to the instances list and just, because it shows up in the normal instances, or is it hidden away just in Murano?
Yes. No, it is also there as a normal instance, as a virtual machine.
Yeah.
Yeah, for example, yeah. And if I connect to this IP address.
And are they always named Murano like that, just to flag them as Murano instances?
Yeah, the name.
Yes,
Yes, the name is chosen by the Murano automatically. So,
There is a stack. There is also a stack associated to it, or is it an instance? There's no stack.
no, yes, there is an stack. Yes.
It looks like the name of a stack.
Yeah.
Yeah. The stack created
12
12
minutes
minutes
ago.
ago.
Yeah.
And those last thing in the environment, you can see also the topology of the application, graphical topology. Oh. Okay. So the server, the virtual server, the application, and the external world. Just very simple in this case.
When did this application component registry started? Because I just checked and there is not that many applications that
Murano, yes, from June or
It was
Kilo
not so
became
stable
very
in June, but from Kilo it has become more stable.
Yes, also the public catalog has become the place where to store packages.
And so people, what are they doing? Are they doing their own private applications or no? I mean, the public space, I don't see that there are that many. The web server and some databases.
We can look at them.
Yes. Yes. You can see the most common application. There also the support for Docker, Kubernetes. Also, maybe.
There is a lot of.
Yes. It's growing up.
Are there specific packages from existing deployments? For instance, you have I have a nice Nginx server with this database and blah blah blah, and I want to create one.
Do you mean to a sort of export of the current deployment?
In Murano from an existing running system.
No, I think so.
It's not.
There isn't the support.
Is it only for Fuel?
No. It's you can add to your OpenStack environment. With Fuel, you can install but just clicking on a button and choose to install or not install Murano. But you can
Yeah, it's like every project in OpenStack. Also manually you can install it if you want.
And you personally have done any of these workflows yourself, or have you actually do a package and how it is when you do like
No written applications, no.
Sorry.
Just test the system, manually the application.
I'm wondering if you have experience with actually
We have
more any sizing.
yeah.
No.
So if you create an environment, then it's a collection of applications, and then you run it.
Yeah.
But then it does allow you to modify the environment, and would that be mirrored in the? Can you let's say in the configuration you selected something and then you want to change it?
Yes, there is the possibility to do some adding a component to already provisioning the environment also to delete component.
Click on that.
Yeah, but, maybe you need to upgrade a component by deleting it and then adding a very different one. Well, that is the idea.
The storage is intact, like your content is still there, right? Even if you delete, or let's say I have others, like the configuration and the content for the Apache. If you, let's say, delete it and then make some changes, and then deploy again, like you're basically reconfiguring or adding a couple of more modules, or let's say adding PHP support and removing the floating IP. Will it affect the config file on the disk or the content as well under the document root?
I think it will use the same resources used before for all the environment, except one that you are changing. Yeah, because if you have already instantiated resources, it uses resources regardless. So if you just delete it and then install it, the application, it uses all the previous used resources. Yeah. Then depends on also on workflow. A lot of things are up to the publisher when it writes that it has to write it into the right mode, the proper mode, so it can obtain a lot of advantages. But if you write it with something missing, so you have not a so flexible environment. But for the end user, it is okay. It is just up to the publisher. Once a publisher has deployed one application, can distribute it on the site, and so everyone can use it. It's not up to everyone to write an application, good written application.
Thank you, guys. Thank you, guys. Just last final words. Thank you, guys, for joining us. That's it. That was it for today. So, yeah, hope to see you soon in the next OpenStack Meetup.